Here we are at problem 2c from our 1.3 set of notes. We're asked to find the limit as x approaches -2 of this particular rational function. Now, there are a couple ways that we can go ahead and do this, but I think just to kind of keep our properties and reinforce those, let's go ahead then and use our quotient property here. So we then end up with being able to apply this limit to the top as well as the bottom. And as a result, we have then the limit as x approaches -2 of x squared minus 2x minus 8 on top, all over the limit as x approaches -2 of x squared plus 5x plus 6 on the bottom. Now, again, you could use the sum and difference with limits, because the sum of the limits is equal to the limits of the sum. And we've talked a little bit about that, but let's go ahead then and just use that direct evaluation. So when we do that, we end up with -2 squared minus 2 times -2 minus 8 all over, this guy should have a parenthesis, -2 squared plus 5 times -2 plus 6. And as a result, we end up with -2 squared is 4 plus 4 minus 8 all over 4 minus 10 plus 6. So just simplifying this, looks like we'll end up with 0 on top over, looks like this will come out to be -6 plus 6. So then that just comes out to be 0. Well, we then end up with a 0 over 0 indeterminate form. And unfortunately, that's just not going to quite help us. Indeterminate. And unfortunately, that's not going to work out. You can't ever have a 0 divided by 0. As you guys know, you can't ever divide something by 0. That's undefined. However, when we're talking about limits, there is something that we can go ahead and use in our arsenal. And that is pretty much just going ahead and factoring this. So anytime you try just direct evaluation like we've done, and you end up with like a 0 over 0, we're going to see that, unfortunately, that's just not going to be able to quite work. You actually have to maybe factor something and get something to potentially cancel. So when we do that, we have the limit as x approaches -2. Factoring this top piece, it just comes out to be x minus 4 times x plus 2 all over, factoring the bottom, we have x plus 2 times x plus 3, and lo and behold, these x plus 2's end up dropping out and canceling with one another. So we end up with the limit, and maybe we'll just draw a little line so that way we know the difference. As x approaches -2 of, with our simplified version, we just have x minus 4 on top still. On the bottom, we have x plus 3. And now we can go ahead and try that direct evaluation. Also, at this point, you could even use your quotient property as well and apply that limit to both of them. So when we end up with the limit as x approaches -2 of that x minus 4 on top. On the bottom, we have the limit as x approaches -2 as well of x plus 3. And now just using that direct evaluation, so we can go ahead and plug in that limit. So we end up with, looks like -2 minus 4, that'll give us -6 on top, over, looks like positive 1 on the bottom. So we end up then with a limit of -6. So for problem 2c, we ended up with a limit of -6. And again, this is a really great example because if you tried just that direct evaluation, I mean, we still applied the properties dealing with like the quotient, as you guys can see on the left. But unfortunately, any time you end up with that 0 over 0 indeterminate form like that, you actually have to maybe try factoring and seeing if something can cancel out. And if you want, you could still use that quotient property like we did here. But then you should end up with the true limit. So again, that is problem 2C from our 1.3 set of notes.